Alright guys, can you do question 4 please?
你们说我怎么设的这样的女孩子？太逗了。这么可爱的爸妈，不一定知道。
We're doing question 4 to 7 this week. So we start with question 4. Alright, have you guys done question 4 yet? Alright, let me show you how to, if you haven't done this. Where am I now? Sorry guys. See? Oh, question 4 here we okay, so you have 2 random samples. The first random sample is from a normal distribution with parameters the mean equal to alpha plus beta and the variance equal to 1. Right now, if you remember from the lectures, guys, if you have a random sample from a normal distribution, the MLE for the mean parameter is equal to the sample mean. Do you guys remember? I think I worked this out during the lecture, one of the lectures some time ago. That if you have a random sample from a normal distribution, then the MLE of the mean, this is the mean, is equal to the sample mean. I proved that result. Well, I did it as an example, guys. If you look back in the scan notes, you will see this, right? So it means that alpha hat plus beta hat is equal to x bar. And similarly, you have a random sample from another normal distribution with parameters alpha minus beta and 1. So by the same argument, the MLE of alpha minus beta is equal to y bar. So MLE of alpha minus the MLE of beta equal to y bar. So you have two equations, equation 1, equation 2, and you need to just solve for alpha hat and beta hat. So if you add 1 and 2, you get 2 alpha hat equal to x bar plus y bar. So alpha hat equals to this. And if you subtract equation 2 from equation 1, you get 2 beta hat equal to this, and therefore beta hat is equal to this. Alright, so this is one way of doing the question, guys, but it's not the only way. It's not the only way to do the question. There are right. Is this guys clear to you or what? Yeah. Are you guys okay with this? Yeah. Yeah. All right. Another way to do the same question. You all right, sir, with this? Yeah. Okay. Another way to do the same question is as follows: is to write down the likelihood function of alpha and beta, which will be the product of the PDF for the x's, which is all right. This guys, this is the product of the PDF for the xi's, right, times the product of the PDFs, n, for the yi's. All right, this is the product of the PDF. So the likelihood of alpha and beta is the product of two products. The first product is for the first random sample, and this is for the second random sample, right? And obviously you need to simplify this, and then take the log. Then you need to take the log of the likelihood, take the partial derivatives with respect to alpha and with respect to beta, and set them to 0. And if you solve these two equations, you will get exactly the same answers that we got earlier. That is the solutions of these two equations will be this and this, right? But obviously this approach is much longer than the first approach, right? Because here you need to write down the likelihood function, the joint likelihood function, simplify the likelihood function, take the log, take the partial derivatives, set the partial derivatives to 0, and then solve the two equations. So this approach, I mean, if I ask you this question in an exam, you can do it this way, but it will be much longer, right? I mean, it will take a lot more of your time. So you would better off time-wise. It would be better off if you do it this way. I mean, both approaches will give you the same answer, right? Okay. Are you guys okay or yeah? Right. Can you do next question, please? Question 5. question 5, you need to know the gamma distribution, which is in the lecture notes. If you look at page 8 of the lecture notes, you will see the gamma density function. Yes, okay. You wanna? Feel free. The rest is purely done. Question 5.
什么拯救我的数学？这游戏真的没错。思考老师讲我不能专心的。
Acting systematic, like for hat.
我在游戏里才是一个男主，一个女的跟我结了婚。
Alright guys, I know many of you have already done question 5, but if you haven't done, you have a random sample from a gamma distribution with parameters r and lambda, but you are told that r is known. So basically the only parameter that is unknown is lambda, right? The parameter that is unknown is lambda. So basically what you have is a scalar problem. It's just what you have is a scalar, that is a MLE for a scalar parameter, right? So you just need to write down the likelihood function for lambda, which is lambda power r. If you look at page 8, guys, you will see this. Alright, this is the density for the gamma distribution on page 8 of the lecture notes, right? Now, if you simplify this, guys, you will get this is what you get, right? The likelihoods after simplification. Take the log. I'm sure you know the procedure pretty well by now. I mean, the procedure for finding the MLE in the scalar case, right? And then take the derivative with respect to the only parameter, that is lambda. So this becomes nr divided by lambda minus sum of xi equal to 0. Set this to 0 and solve for lambda. You get lambda hat equal to nr divided by the sum of xi which you can write as R divided by the sample mean. Now, because this is a scalar case, you must show that this is indeed an MLE. Now, how do we show that? To show that this is an MLE, you need to find the second order derivative of the log likelihood, which is minus nr by lambda squared, which is a negative number, right? Hence, lambda hat is an MLE, right? Alright, so that proves the first part. Now, to prove the second part is just trivial, because what you have here is a function. What you have, this is tau, guys, not to be confused with R. It's a Greek symbol tau. What you have here is a function of lambda. So the MLE for the function is simply what you get by replacing lambda by lambda hat. So the MLE for tau is simply 2 lambda hat minus 1 squared, which is 2r divided by x bar minus 1 squared. Right? I mean, this is known as the invariance property of MLEs, which says that if you know the MLE of a parameter, then you know the MLE of a function of that parameter. Yeah. So that's the property I have used here. Yeah. Okay. All right. All right. Can you do now 6, please? Question 6 is similar to question 4. Sorry, man. Yeah. Thank you for it. It should be R over X bar. I copied this incorrectly. R divided by X bar, guys. Okay. Sorry about this. That's all. I'm sure you spotted this. Yeah, guys. then because this is a function of mu, just the same procedure here. Because this is a function of mu, the MLE for the probability is just what you get by replacing mu by mu hat. So in other words, it is phi h minus mu hat. Yeah, is the MLE. Yeah, to find the MLE of this probability, right? This would be equal to phi at minus mu. Now mu hat is the sample. Usually the phi s minus is the sample. The sample mean you need to compute it using the data here. So you need to sum all these numbers and divide by 0. Yeah. Alright guys, so question 6 is kind of, you can do it in multiple different ways. Question 6 is similar to question 4. So I'll show you once again the two different ways you can do question 6. Alright, the first approach is as follows. You guys, I don't know whether you remember, but several weeks ago I did this example in the lectures, and I showed you that if you have a random sample from an exponential with parameter lambda, then the MLE for lambda is equal to, do you remember what it was? 1 over x bar. So because of that, so the MLE for lambda 1 is equal to 1 divided by x bar. Yeah, and by the same argument, you have a random sample IID from exponential distribution with parameters lambda 1 and lambda 2. So by the same argument, the MLE for the product is equal to 1 divided by y bar. Okay. So in other words, the MLE for lambda 1 multiplied by the MLE for lambda 2 is equal to this. Yeah. So you have two equations. Yeah, and you can solve for the two unknowns, right? So if you divide 2 by 1, you get this. And lambda 1 hat is of course 1 divided by x bar. So this is a short way to do it, or the shorter way of doing it. The other way to do this is to do what I said before, that first to write down the are you guys okay with this or not? Yeah. All right. The second way to do it is as follows. So this is question 6 one more time, right? So is to first write down the joint likelihood of lambda 1 and lambda 2, which will be the product. This is the product corresponding to the first sample, and then multiplied by the product corresponding to the second sample, which is this one. So you have two independent samples. The first product is for the first sample, the second product is for the second sample. So you need to obviously simplify this to find the likelihood function, and then take the log of the likelihood function, and then take the partial derivatives with respect to lambda 1 and lambda 2. set them to 0, and solve them, and you will get the same answers, guys. But obviously it will take a lot longer. I mean, you will get the same answers, but the process will be a lot longer, okay, as you can see. Because first you need to simplify the likelihood function, then take the log, then take the partial derivatives, set them to 0, and solve the two equations. So these are the these are the two ways to do this, right? They're clear, guys. Yeah. Yeah. All right. And you guys do question 7 now, please. Question 7. Yeah, just use one of the 3 rules now. You use the correct one to figure out. You know, sir? You guys done question 7, guys? All right, let's. I know. I mean, like after you do a certain number of questions, you will know when the standard approach will not work, and when it will work, and when it will not work. But in this case, I mean, you need experience to do that, guys. But in this case, I know the standard approach will not work, but I will show you that anyway. So if you first apply the standard approach, guys, if you apply the standard approach, this is what you get. You get E n delta minus the sum of xi. Yeah, and then take the log. You get n delta minus the sum of xi. And then take the derivative with respect to delta. You get n equal to 0. It doesn't make any sense. Right? So clearly the standard approach does not work. I mean, in the exam, if you think the standard approach will not work, then you don't have to show that. I mean, you go straight to the indicator function approach. But for that, I mean, to get that kind of experience, you need examples. You need to do lots and lots of examples to get an idea about when the standard approach will work or will not work, right? So I'm going to do the So I'm gonna try the indicator function approach. So which will be, so you need to rewrite your your likelihood function and put the indicator function that each xi is greater than or equal to delta, because you're told here that x must be greater than or equal to delta. All right. So if you take the product of these guys, you get this. Now this is where you need to simplify. You remember in the lectures I gave you three rules for simplifying products of indicator functions. Now what would this simplify to? I mean, you must remember the three rules, guys. What do you think this will simplify to, guys? Yeah? Yes? No? I'm sure you guys know this.
The minimum of xi.
Yeah, exactly. The minimum of xi greater than or equal to delta. Just try to try to remember those three rules, guys. I gave it, it's in the scan notes I gave you, all right? So this reduces to this, yeah? And the next thing you need to do, guys, is to plot L of delta versus delta. Suppose this is your min of xi, yeah? Now, we know that if delta is over here, right, then this condition is not satisfied. So this red is flat 0 over here, guys. It will be all the way, it will be 0 here. Now at this point, on this side of the of this point, how do you think the graph will look like? It's easy, guys. But it will be what? It will be, yeah, it will be an increasing function. Okay. And I know it's not a good graph, but this can't draw better than this, guys. Sorry. It's an increasing function because you have E of n delta, and n is a positive number, right? Therefore, as delta increases, this must be an increasing function, right? So therefore, the largest point, this is the largest point of the graph, and therefore the ML estimator for delta must be equal to the min of xi. Yeah. All right, guys. I know we did several examples like this in the class, so you must know by now how to do this, guys. Yeah. All right. Now, about yesterday, we did sampling distributions, right, in the lectures yesterday, and I was only able to prove 3 of the properties. Now I know you have midterm tomorrow, but after the midterm, can you guys have a go at proving the remaining properties, the ones I did not have time to prove? Are you guys okay with that? And if you have difficulties proving, just contact me by email or in person. I'm in office all the Tuesdays to Friday, 11 to 5. So you don't need to make an appointment to see me. Just drop in, okay? My office hours are I forget what my office hours are, but it's on the website anyway. But you don't need to stick to the office hours. Just drop in anytime between 11 and 5. Tuesday to Friday. Usually the function is takes the value 1 or 0, depending on whether the event is true or false. That's it.
So every time the mirror of x and the x and delta
Returns 1. Returns 1 if it's greater than equal to delta. Returns 0 otherwise.
it shows the
If you're on this side, then delta is greater than the mean of xi. Delta is greater than, although this side is delta is greater. So that means on this side, if delta is greater than the mean of xi, that means the condition is not satisfied.
it's on the left side.
Yeah, left side it is satisfied. Yeah. On the left side, yeah, it is satisfied. On the right side, it is not. Yeah. This midterm, just come to this
I'm suddenly thinking that you're more midterms this class.
It's term is 65.
I certainly won't. Wait, because they're attached to their number.
I'm just trying to say good luck for you guys. And good luck for tomorrow.
That's what I'm doing.
You're not doing
Fine.
You're not doing So you haven't had any midterms so far?
No, I've just got
Yeah.
Remember, because on the right hand side, delta is greater than m.
Yeah.
That means that the condition cannot be satisfied. So according to the condition, delta must be less than equal to 1. Which is the left hand side. Just think about it. If you have questions, just see me.
没事吧？我逗号哎，我跟他说了，1年前其实没想起来。
You okay? You still have problems?
Yeah. So this just derived from
What is
normal,
it?
when you just remember the things.
Yeah. Probably.
And so for this kind of what we
然后那个微保上的负电不是10
No. I will give you a list of formulas. If you look in the website, the first website, there is a list of formulas you need to remember for the exam and also for the test.
然后就
Yeah, it's not very long. It's not very long.
恶心啊！
Yeah. Alright. See,
没有，我看他那个algebra structure 是要到后面。
you guys okay?